Hi, seventh graders. We are going to talk about area parallelograms and triangles today. And so you may have actually learned about the area of parallelograms and triangles in elementary school. So this is going to be just kind of a review to get everyone back on the same page. So first of all, as a reminder for that definition of a parallelogram, when we talk about a parallelogram, that's going to be a quadrilateral. So 4 sides with opposite sides, with 2 sets of opposite sides, parallel and congruent. Remember, this word congruent means equal. All right. So when we're talking about area is now going to be referring to the space inside a shape. And then more specifically, like the number of square units inside of a shape. Before, we have been talking about circumference and perimeter, so that was all focused on the outside edges of the shape. Now we're focusing in on the inside of the shape. And so we'll have lots of area formulas. You'll have a formula reference sheet that you'll be allowed to use. I'm not expecting you to memorize formulas here, okay? But the formula is going to be like a guide that tells us exactly what to do to figure out our answer that we're looking for, okay? So when we talk about the area formula for a parallelogram, it's A is going to equal BH, okay? And since there's no operation symbol here, we're multiplying that B and the H. So where the A represents area, B represents the base, and H represents the height. So you're going to find the area of the parallelogram by multiplying the base and the height. So, and one thing you need to know about the base and the height is that they are always perpendicular to each other. So what that means is that they intersect to form right angles. So if we just wanted to practice a little bit labeling a base and a height on these parallelograms, again, we're looking for those, we're looking for the 2 measurements that are forming right angles. So on this first parallelogram, here's my right angle right here. And so this dotted line down the middle there is my height of the parallelogram, and I can say that the bottom part is my base. On this rectangle, I can say base and height. There's my base and my height there, and my base and my height there. So this would be the base, this measurement, and the height is this dotted line. So when we use the formula, okay, the first thing we want to do is we want to be able to write the formula. The formula tells us exactly what to do. So I have a parallelogram, I'm finding the area. I'm going to be using my formula, A equals base times height. So now I'm going to substitute any known values, all right? Remember, our formula is made up of all these variables, so now I'm going to plug in what I know. Well, I don't know the area yet, but I'm going to look for my base and my height, and I'm going to remember that they are perpendicular to each other. So they're going to form that right angle. So I see a right angle is formed here, and so that's with this measurement of 6 centimeters and the measurement of 5 centimeters. So I'm going to plug in 6 times 5. And so 6 times 5 is going to be 30, which means my area will be 30. And then when we label area, we label it in square units. So square centimeters. So on this first example here, if I wanted to find the area of this rectangle, I'm going to start with my formula, A equals base times height. And then we are going to go ahead and plug in what I know. So my base and my height are 5.5 and 4. They're perpendicular to each other. And so if I multiply those, I'm going to end up with 22. And again, I could say square centimeters or centimeters squared is another way that you'll see area written. All right, now notice on number 2, we have a lot of measurements here. And so when we're looking for the area, always start with that formula. The formula is your guide. Okay, so base times height. So I need to figure out my base and my height, and I need to remember that they are perpendicular to each other. That means I'm looking for the measurements that intersect to form a right angle. So here's a right angle, which means that the 2 and the 7 are my base and my height. So 7 times 2 is going to give me an area of 14 square centimeters. All right, so I'd like you guys to go ahead and pause the video and try a couple of examples on your own, and then I'll end up working these out. So go ahead and pause the video right now. Okay, so on this first one, number 1, always start with your formula. A is equal to base times height. Base and height are perpendicular to each other. They form that right angle. So when I see the measurements that form a right angle, that's going to be the 6 and the 7. So I'm going to multiply 6 times 7, and I'm going to end up getting 42 square meters as my final answer. Number 2, I'm going to start with my area formula. A is equal to base times height. Here, both my base and my height happen to be the same numbers because this is a square. So 4 times 4 is going to give me 16 square centimeters. Number 3, I start with my base times height formula. I'm looking for my base and my height that are perpendicular to each other, and they intersect to form the right angle. So that's going to be the 9 and 3.5. So I need to multiply 9 times 3.5. And when I do that, I'm going to end up getting 31.5 square feet. And number 4, again, start with your formula. A equals base times height. We're going to end up multiplying 2.5 times 5. And when we multiply that, we're going to get 12.5 square yards. All right, number 5, we have a word problem. The first step to a word problem is to read it. So Cindy is making a display for a project. She plans on placing 100 stickers that are 2-inch by 2-inch squares on a poster board. The poster board she's using has a length of 3 feet and a width of 2 feet. Does she have enough room for all of her stickers? So we know that we need to figure out the area of each sticker square. All right, so 2-inch by 2-inch is going to be 4 square inches. And we know that she has 100 stickers. So if each sticker has the area of 4 square inches and we multiply that times 100, that's going to be 400 square inches that we need. So her poster board has a length of 3 feet and a width of 2 feet. And so here we want to convert our feet to inches. So 3 feet would be 36 inches. There's 12 inches in a foot. 2 feet is going to be 24 inches. So now if we find the area of our poster board, multiply 36 times 24. And we get 864 square inches. So yes, she will have enough room for all of her stickers on there. Number 6, the area of a basketball court in the NBA is 4,700 square feet. The court is 94 feet long. What's the width of the basketball court? So here, we're still going to use our formula, but this is actually giving us the area. So we know the A is 4,700. The court's 94 feet long. And so it's asking for the width. We could say that's basically the same as the height. And so I have 4,700 is going to equal 94 times something. So to figure that out, we can divide by 94. And when we do that, we get 50. So that means that the width of that basketball court is going to be 50 feet. All right, that was a little bit about area of parallelograms. Have a great day.